Let's move on to our last example for chapter 1, section 1-1. And this is now dealing with the equations of perpendicular lines. Find the slope-intercept form of the equation of the line that passes through the point 2, -1. So same point. And is perpendicular to the line 2x minus 3y equals 5. So this is actually the exact same setup as last problem. And the only word that changed now is perpendicular. And this is now going back to geometry, what you learn about perpendicular lines. And so probably many of you are very familiar with this. So let's just review this quickly. And that is that two lines that intersect, that create a right angle. So if this is line A and if this is line B, then we would say that line A is perpendicular to line B. Okay, so this is the notation for that right there. Okay, so and you learned that back in geometry. So line A is perpendicular to line B. Okay, that's cool. So that's what perpendicular means, but we need to talk about their slopes though, because that's actually what's going to be helpful to us in this right here. And you should have learned in geometry that say if this slope right here, like I'm going to call this slope right here, and now I'm just going to use variables now. I'm going to say that this slope right here is x over y. Okay, let's just say if this slope is, rise 2 over 3 or rise 5 over 9. Okay, something like that. So just some x over y. So slope of A is x over y. Do you know what slope B will automatically be? What B will be. Do you know what the value of the slope is going to be for line B? Do you know what it's going to give us? You should know that the slope of a perpendicular line is going to be what we call the negative reciprocal, meaning if this was positive, then it becomes negative. Basically, you take the opposite of this, and then you do the reciprocal, y over x. Okay, so let's just do a few little small examples here. So if my line A had a slope of -2/3, okay, if one of my lines was -2/3, say this one, right, what would the perpendicular slope be then? It would be the negative, which means that it's now positive then, and then reciprocal, so 3/2. So these two slopes would be perpendicular slopes. How about if I gave you a slope of -1? Okay, well, let's think about this. I want the negative reciprocal of this. So first, negative means the opposite. So it goes from negative to positive. Okay, and now we have to flip 1. Well, 1 is the same thing as 1 over 1. So if I flip 1, doesn't it just become 1 over 1 or just 1, right? So basically, the reciprocal or the perpendicular slope of -1 is just 1. And let's just do one more here so that we're, say if my first slope is, I don't know, 0.5. Okay, let's just say if it's 0.5. Well, 0.5, let's think about this. 0.5 is the same thing as saying it's 1/2. So what's the negative reciprocal of 1/2? Well, it's negative, and then you flip it. So 2 over 1 or just 2. Okay, so here's the idea of perpendicular. If you have two slopes that are negative reciprocals of each other, then we know that when they cross, they're going to make 90-degree angles. So that's going to be helpful to us in this problem here. So we need to write an equation in slope-intercept form, given this is going to be our point, but then what kind of slope are we looking for here? We should be looking for the negative reciprocal. So let's first find m, and then we're going to take the negative reciprocal to find our new m. So 2x minus 3y equals 5. And we solved for y last problem. So we'll do it again. Minus 3y equals negative 2x plus 5. So I divide by, or I'm sorry, I subtract 2x. And then I divide by negative 3. So I get 2/3 x minus 5/3. So this is my slope, right, of this line right here. It says to write an equation that's perpendicular to this line. So I know that my new slope must be the negative reciprocal. So the negative reciprocal is going to be a negative 3/2. Okay? And so let's, and then we also have our point right here, right? The 2, 1, 2, -1. So now that we have a slope, Now that we have a point, let's go ahead and find our equation using point slope formula. Okay, so let's plug in, I'll change my color here to black. So let's plug in x1 and plug in y1, and this is our m. So y minus -1 equals m, -3 halves, times x minus 2. This right here becomes y plus 2. I'm sorry, y plus 1. Just erase that real quick. Okay, so y plus 1. -3 halves x, use the distributive property, and this right here is going to give us a, if you multiply -2 by -2, let's think about this. 2 can divide into -2 one time, right? So this is like a -1. So -1 times -3 is going to give us a +3. That's kind of cool right there. And then we subtract 1. So y equals -3 halves x plus 2. So if we look here, I know just by looking at the slopes, that's all we care about. We don't care about the y-intercepts. By just looking at their slopes, I know that these two lines are perpendicular, that they're going to create a 90-degree angle, a right angle, when they intersect. Okay, so there's that guy and there's that guy right there. So if we were to graph these guys, a quick sketch, just to see what these guys are kind of looking like here. So we'll go -5/3. So -5/3, that's about -1 point something, so about right there. And up to over 3. Okay, so draw my line right there. Look something like this. And let's do our other guy right here. Y-intercept is 2. So we go up to 1, 2. And then the slope is -3 over 2. So down 3, 1, 2, 3 over 2. Okay, draw our line. And this is a sketch. Kind of looks like it's 9 degrees. It's supposed to be 90-degree angle right there. And so we would know that these two lines, when they intersect, are going to make a 90-degree angle or a right angle right there.